Do you guys have a problem? Remember how I told you guys, don't fix a process, problem. You can use Six Sigma in hospital waiting times. You can use Six Sigma in reducing a part. You can use Six Sigma in reducing your lead time. You can use Six Sigma in your simple chemical composition. The composition should be whatever percentage of water, X, Y, Z, and am I achieving that? So Six Sigma takes data, and it throws and it sees, am I hitting the center point or not? Whatever that center point is. In your case, it's volume of mixture of carbon in X, Y, Z. Anything that can be measured, you can use Six Sigma. For everything else, God is there, which is lean. Anything that you cannot measure, you can apply lean just by looking at process, just by. I'm not saying lean doesn't need measurement, we do measurement, but don't go crazy. Engage the people, people will give you the waste. And then you just measure the end point, the total lead time has improved. Lean focuses on eliminating the waste, which already has the variation in it. Six Sigma focuses only on reducing variation and improving the process capability, making the process more capable, more towards the, we call it nominal reading. Do you know the meaning of nominal? Nominal means 65 millimeter, plus minus 2 is the variation. And my variation shouldn't go beyond plus minus 0.2. I shouldn't be producing a pen which is 61. I shouldn't be producing a pen which is 68 millimeter. Always the goal is 65, plus minus 0.2. Most of my readings should be at the top, center 65, and some of the readings should be going normally distributed. Make sense? The Dmacc approach, which is Six Sigma approach, define, measure, analyze, improve, control, is already embedded in A3. You call it Dmacc, we call it A3 problem solving. Same. Who cares? How many people know about this? How many people know about this? 95% of your problems in your life, in your world, anywhere, any problems you have can be solved by these 7 QC tools. For the 5% of the time you need Six Sigma, normal distribution, you need CP, CPK, PP, PPK, whatever you, statistical tools. How many people have heard about these things? Cause and effect diagram, fishbone diagram, Ishikawa diagram. How many people have heard about this picture, this diagram? Lots of people have heard about it. Histograms. Remember your school days? We used to do a class weight size, 70 to 80 kilograms, 80 to 90 kilograms, 90 to 100 kilograms, and we used to put 70 to 80 kilograms, there are 3 students, 80 to 90, there is 7 students. I'm not teaching 7 QC tools today, it's covered in my green belt training. You will come and you will do in Excel, you will do all these graphs in Excel, okay? I have already worksheets. Flow charts. We're going to do value stream mapping, we're going to do swim lane mapping today, so don't worry about it. I'm covering flow chart. Check sheets. You guys use check sheets every day in one form or the other. Example of a check sheet is a bidding document. It's already asking, put down all these information in the right places. You ask people your name, your company name, your age, blah, 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 blah. You have check sheets all around you. Scatter diagram, especially for your industry. Scatter diagram, and maybe in your industry, in welding industry, you may use where you want to see if I increase the pressure, what happens to the temperature, where you have two variables. Who uses scatter diagram? You guys use it? Where do you use it?
The chart, the general progress of jobs relative to how many hours they're tracking.
Perfect. Perfect. So there is 2 variables, and you just see, is there anything?
Correlation.
Yes. Correlation, positive correlation, negative correlation. Again, this is not a stats class. I'm just telling you. These are 7 QC tools. Then comes run chart. I'm pretty sure everybody has seen run charts. Stock exchange. Right there. Control chart. What is the difference between a run chart and a control chart? Control chart has limits. 65 plus minus 0.2 millimeters. So what is the minimum? 64.8. And what is the maximum? 65.2. And every pen I'm producing should be in between that 2 readings. I shouldn't be going above, I shouldn't be going below, which is similar to normal distribution curve. And last but not least, Pareto Analysis. I have fallen in love with this tool for my life. I'm a servant of this tool. Pareto Analysis. How many people know about Pareto Analysis in the room? 4 people. Italian scholar, Mr. Pareto, said 80% of the world's money lies with 20% of the population. That was 17th century or 18th century. What is the truth today? 98% of the world's money lies with 2% of the population. So the focus is, you have all these issues. Remember I was telling you building permit process? There are 60 different type of issues why as an examiner he can reject the file. But when you start to put down the numbers of all the 1,000 files you have rejected, you will start seeing only 7 top reasons, which gives me 80%. Okay, I'm going to do an exercise. Because I've fallen in love with this tool, I'm going to do a quick exercise. Okay, just throw me different type of problems you get. What kind of problems you get? Give me 2 problems. Missing part?
Yeah.
How many? Just throw me a number per month. Per month. Just throw 100. Okay? Second problem. Paint defects. How many problems you get every month? Throw me a number. 20. 50? Okay. Anyone else? Give me some list of problems. What kind of problems you see every month? Throw me a number. Throw me a number. I'm teaching you Pareto Analysis.
Defective harness.
Sorry?
Defective harness.
Defective. Just think you guys work in the same company and these are your defects. How many?
5.
Return paperwork. Defect. Very good. How many times?
25.
Defective armrests.
Give me the real number. Because it will be very obvious. But give me some kind of, yeah. More? More?
Stopped rails. 15.
Stopped rails, 15. And I'm just going to throw some numbers now. 1, 2, 3, 4, 5, 6. You calculate all this data and you throw in Excel like this in a list form. Then what do? You take this data and you convert this data into 100, 50, 25, 20, 15, 5, 4, 3, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Make sense? What do you think Pareto Analysis tool is? It tells you, if you do a percentage, let's say there are 100 type, 260 type of defects. Let's say this is the total of 260. What is this?
Biggest piece of it.
100 divided by 260, calculator?
40%.
100 divided by 26, 260.
38%.
50 divided by 260, 9.5%. 20 divided by 260, 9%. Okay? 20 divided by 60, percentage I'm asking. 20 divided by 60? Sorry. So then this was also wrong. 20 divided by 260. 20 divided by 260 should be around 8%. 8 or 9.
Sorry, you're right. 8%.
Yeah. Okay? 15. I'm just going to throw the number, guys, just for your, just 5%, 4%. What Pareto tells? Pareto says you have to find, you have 100 issues, find your top issue. What will you be focusing? Remember Dandapani? You will be only focusing on these issues. When you total this, 38 plus 19, give me a number. 57%. 57 plus 9.5. 66.5. 66 plus 0.5 plus 8. 74.5 plus 7. 81.5. Only focus on these issues. Forget about what I'm seeing in organization. People are working on this problem. People are working on this problem. People are working on this problem, which is only one. And we don't know where our focus should be.
81% of your issues are in the
81 issues are out of my 100 issues. 5% of my issues are causing me 80% of the grief. Guys, do you understand the meaning of Pareto?
So is that a variation on the 80-20 rule?
This is the 80-20 rule, Pareto analysis, but there can be variation on the 80-20 rule, yes, depending on your problem. When he did at that time, if you have a large database, probably you will be right. But sometimes one big problem in an organization can have 1,000 issues that month, goes to the top. But if you collect over a period of year, then maybe you will find 80-20 rule applies. Guys, you hear that, right? Every day, 80-20, 80-20, 80-20. Did you guys ever try to find out what is 80-20? I have fallen in love with this tool. I hope you guys will. Gemba walk. Again, you have heard a lot about Gemba walk, Gemba walk, Gemba walk. Go to the source, touch and feel the process, understand before making decisions. Now is the time you have to go where the problem is. Okay? Please take a process walk around your problem, understand the problem closely, go to the shop floor or where the problem occurs, meet the people who are close to the problem, interview the problem firsthand. Don't go by hear and say. Okay? Try to understand the symptoms, the causes, and find out more details before start to problem solve or doing real root cause analysis. Again, Gemba is where the work is. Now we're going to talk about some KPIs, some numbers. Number of leaks. Remember QCDMS? I taught you QCDMS at organization level. You have to have QCDMS at each process level also. How do you know your process is doing good? Having key KPIs at QCDMS at organization level will not help you. Your windshield water leak, your welding line KPIs, your paint KPIs, your engine assembly KPIs are all connected to plant KPIs. Does it make sense? Same thing in your sense. If you're trying to reduce the number of defects, mechanical defects, electrical defects, electronics defects, okay, whatever those type of defects makes your overall defects. You cannot improve defects by chatting, by having a discussion up there. Nothing will change if you don't go to the right place. Same thing, you're trying to reduce view tech defect. What is your PPM? You have a PPM by plant? What is your PPM? 15 PPM target. Be honest, what is it?
We actually get pretty close. We get
This is external or this is internal?
external.
Okay, I was going to challenge you.
Actual.
I know the answer.
But external.
Do you know the meaning of PPM? No. Rejection, parts per million. You make a million product, how many rejections customer is rejecting? Their target is 15 per million. Internal, I can tell just by looking at his face, it's around 1,000 to 3,000.
Between departments.
Yeah, it could be more. Yeah, that's what manufacturing plants are. They reject a lot internally, but if you have a huge PPM inside, rest assured you will have some flowing. It's not able to control. If your PPM is low in the plant, you will have low PPM going externally. Make sense? So nobody heard about this PPM philosophy. It's connected to Six Sigma theory, 3.4 defects per million.
3.4?
That's what it is, 3.4. So you guys are around 5 or 4 or 5 Sigma. If you want to be a 6 Sigma, you're not actually, you're not. So you are 1 or 2 Sigma because you have 2,000 to 3,000 at the source. You are controlling it by quality control. You're not producing to 3.4 parts per million. Are you guys understanding the meaning of that? 6 Sigma companies, 3.4, and then 5 Sigma, 4 Sigma, 3 Sigma, 2 Sigma, 1 Sigma, and 0 Sigma companies, which has 50-60% rejection rate. The meaning of that is, if you make million planes, or if you do million flights, only 3.4 flights should have issues or should fall from the sky.
That's a horrible example.
It is, but if you multiply the number of flights happening in the world at any given time or in a day, and that's how they tell you, right? We are better than 6 Sigma. How many people have heard about Indian dabbawalas? Nobody has? Indian dabbawalas? It's a great case study. There is a hot food supply chain management since 18th century or 17th century in Mumbai, and they always deliver your hot food cooked in your home. They take it from your home and they deliver to your workplace, because it's very hard in Mumbai to carry a lunchbox because the trains are jam-packed. If you've seen China or Japan trains, it's even worse than.
Your lunchbox, like going back and forth, like from home to work.
And they never miss.
Never miss, like single day.
Talking about the SIPOC, we haven't walked the process actually. Okay, you have this process walk template. You can just write it by even hand. I don't mind. It's just a template which says, what is the problem? Which organization? Who is doing the process walk? I'm at the source. I'm going to look at the conduit process. I'm going to look at the parts process. I'm going to stay there for 1 day or 2 days and just watch what do you do when the parts are missing. Okay? I'm going to come and see how we are suing that issues, wherever that sub-assembly is happening. Make sense? Detailed process steps. Take your initial SIPOC and go into the depth of each step. Maybe whatever you have written here, go and watch the step. Maybe it will open up 1.1, 1.2, 1.3, 1.4. Go to the as much as detail as possible. Go and watch that person putting the leather, putting the plastic, and sewing machine. Watch the cycles. Just watch and see what can go wrong. What can go wrong? Human-related issues which can cause your issue. What can happen on the machine or computer-related issues which can cause your issue. What can happen on the material side which can cause your issue. Ask yourself while watching the process. But first you need to know about your problems. If you don't know about your problems, that I'm having 65 nicks and 35 thread issues, how do you know? Why? Because you're not looking at the right point. You're not focusing in the right place. That's why I'm teaching you Pareto analysis is very important. You have to open it up. Same thing I'm asking them. Did you realize all of you have the same issue? I asked them, tell me how many times we had project issues, how many times we had failures in the project, which did the delay. They don't have a data. I asked you. Sorry, I'm just trying. This is the other challenging thing I told you I will challenge you. I asked you, okay, where are the delays? Same thing, you guys are same. You are preparing a truck to go on the road. They're preparing a whole building. Same thing. You don't have data. They don't have data. Maybe you have data because you're in manufacturing. Maybe you also don't have data. Maybe we're just rejecting. Same thing on your end. Where is the data? Data is power. Data, it takes energy, but it will tell you what it is. Okay? Any thoughts on this tool? This is now you're walking the process.